In the case of wide area networks, we have some choices as far as how we're going to interconnect across a service provider. If you don't have too many sites, usually what you want to do is set up a full mesh topology. Now, a full mesh topology means you have one connection from one site to every other site within your network. Now, usually in a wide area network, this would be the ideal way to do it. The problem is that a full mesh topology can become very expensive. And the reason it's expensive is because there's a geometric progression formula that goes hand in hand with building a full mesh topology. That formula is n times n minus 1 divided by 2. Really what that is the number of sites, n, times n minus 1. So if you have 10 sites, for instance, so n is 10, and you take 10 minus 1, so 9, so 10 times 9 is 90, divided by 2, 45. That's 45 connections you need to build a full mesh topology between those 10 individual nodes. That can get very expensive, especially considering, what happens if I have 100 sites building a full mesh topology. So building a full mesh topology through a carrier can be a very expensive way to build a network and usually isn't the best way to do it. So a better way to do it, if you've got a lot of different connections, is to go to more of a partial mesh topology. Now, partial mesh is really a trade-off of cost versus redundancy. Oftentimes in a partial mesh topology, you'll have one centralized site and then other, say, regional offices that get a lot of traffic that need to be interconnected with high-speed connections to the central sites and so on, and are more logically directly connected to small offices and so on. So you end up looking at your WAN design and you end up really with this partial mesh topology. Now, partial mesh works really well and it's a great trade-off, but there's some disadvantages to it as well. You start dealing with TCP/IP, and the routing mechanisms don't really like partial mesh very well, and you end up having to break it out into point-to-point links over a large network, and it can be a bit of a pain to deal with respect to your routing protocols. Another way to configure a wide area network is based on hub and spoke. Now, if you look at hub and spoke and you compare it to the star topology, it's actually the same. It's just the difference in name really is hub and spoke, star topology. It really is the same. But commonly, when we're dealing with wide area networks, we often talk about the hub and spoke type technology, and it's slightly different with respect to a wide area network, because usually at the hub site we have a difference in bandwidth. So the bandwidth at the remote end is going to be considerably slower than the bandwidth at the head end or the headquarters side of this connection. So I just put it in here for completeness, even though it's pretty much the same topology type as we see in a star topology. So now let's jump back into Ethernet a little bit. And actually we got a lot of talk about Ethernet in this course. We're going to focus on how things actually work from a physical layer with respect to an Ethernet network. So we're going to start off with a network card. Typical network card you'd see inside of your PC. Now, it may be an actual physical card like this, a PCI card plugging into a PC, or it might be a pre-built-in RJ45 Ethernet connection on the motherboard of your PC, or you could buy the high-end super gamer network card that's currently running at $200 US here at the local Fry's Electronics, which I have no idea why those are so expensive. I'm really tempted to go out and go spend the money and look at it, test it to see if it actually does the things it says on the back of the box and have a special processor for handling things like this, and if it actually does get the performance level it's saying it can based on these $200 network cards for gaming purposes. But needless to say, a network card is a network card. A funny thing I often hear students say is they talk about NIC cards. That would be the acronym NIC, N-I-C, Network Interface Card, and they always follow it with the word card, which is a little redundant, right? NIC card would be the same as a Network Interface Card. So, anyways.